Record it on the computer. Why not? Don't know where we'll go, but apparently it's recording somewhere. Okay.
Okay.
So what we would want to do is we first cleared fractions. Now, are there any questions on how we did that? Should we do that one more time, or it made sense how we cleared fractions?
Well, you found the lowest common denominator, and then you just canceled out the denominator.
Yes, I did. Exactly right. Okay, so now this is the point about checking, and a lot of people don't do the final step. So I consider this right here, B, oops, I meant draw, not erase. B, so we have B equals -1, okay? And I normally would use a lot of different colors, but I don't actually know how to change the color on this pen right now.
Right.
So what I could do is I could go back. Now what we would do is we'd go back to the original problem, and we would plug in for B, we would plug in -1. So anywhere we see a B, we're going to plug in -1 to see if it works. So this is called the check, right? Does that make sense? You've heard about the check before?
Yeah.
Okay, so here what we would do is we would say, okay, well, I want to know if -1 works, so I'm going to check it. And really what I expect students to do is on every problem, especially when you're doing a problem that's graded, I expect people to check because you want to know it's correct. So
Right.
you would plug it in, and this would be called your check, and you would get -3/2 plus 4/3 equals -1/6. Then you would do your same thing. Like, you're going to get a common denominator, right, in order to add these fractions together, right? -9/6 plus 8/6 is equal to -1/6. And usually when we plug it in, we don't know if they're equal, so we put a question mark until we see at the end that they are equal to each other. So the check is what confirms that your answer is -1. So then you would say the solution is -1, and we use that set notation.
Okay.
Does that make sense?
Yeah.
Okay, so let's go ahead and look at the next one. I didn't look at it yet. Why don't you just tell me, can you try reading me the problem and we can see from you?
Yeah. Yeah, I just sent it to you so you could see what me and the 14-year-old tried to do.
Oh, that's really cute that you were working. That was good practice. Too bad he got him wrong. Okay, just go ahead and read it to me because my email is buried. So
7 and then in parentheses B -3 minus B equals -169 minus 5 in parentheses 4 plus 3B.
Oh gosh, lots to do here. So the most common errors, do you know what the most common errors are in these problems?
The minus signs.
Yes, exactly. And also distribution. So first we would start with distribution, right? So we would get 7B minus 21 minus B equals -169 minus, what would you get if you distribute here?
20. And then I have -5 and then in parentheses plus 3B.
Okay, so we're going to multiply that. So it's going to become
-15.
B, yes. Does that make sense?
Yeah. Okay, so that's where the mistake was. I didn't do that right off the bat.
Okay, so then we might as well, should we finish solving it?
Yeah.
Okay. So what would we do next?
So you combine the like terms. So it's 6b minus 21 plus 21.
Okay, because you're gonna add 21 to both sides.
Yeah.
Okay. And then
And then minus 194 plus 21.
okay, and where does 194 come from?
I think that's where my mistake.
Oh, because we're adding
from the 15 was. Yeah.
Okay, so we're adding those together, so that's going to be, or we're subtracting them, however you want to think of it. Okay, so that's going to be, what is that?
169. It would be minus 189.
Good. Minus 15b. Okay, and then you were adding 21 to both sides, right?
Yeah.
Okay. And so what would we get now?
You'd get 6b. You'd get 6b. Okay, so you would have to subtract 189 from both, or you would have to add 189 to both sides.
Well, okay, I guess what got confused about is when you were telling me this step, you told me minus 21 plus 21. So
I need to do that one. So 189 minus 21. So it's minus 168.
168, good. 168. And then we still have our negative 15b, good. And what would be the next one? I figured out how to get new colors.
Oh, good. Okay, so then you have to add 15b to both sides.
Mm-hmm. Okay, add 15b. And we get?
And so it's 21b equals a minus 168. Okay. And then 168. And so the answer is 8.
Is 8. And is that because you divided by 21?
Yeah.
So
so it's minus 8. The answer is minus 8.
Minus 8. Okay. Now, so what we're going to do is we're going to take that, b equals negative 8. How can we be sure that this answer is correct?
So you have to put 8 in where b is.
Yes. So we're going to erase all of this with my little tiny eraser that I probably could have made bigger somehow. And we're going to plug in negative 8. And we always want to go back to the original equation, okay? Because if you go into a simpler version, you might have made a mistake someplace else. So we're going to plug it in here. So we go 7 times negative 8 minus 3 minus negative 8. Now, it's really important that you keep that minus, but you have minus negative because that changes things, right? 169 minus 5 times 4 plus 3 times negative 8. Okay. This is these are the hardest of the hards. These are the hardest problems to solve. Okay, so now we're plugging it in. So what would you do first to make sure? And we don't know that it works yet. So this is our check.
Okay.
And
so,
yep.
So you do it's going to be minus 56.
Where's the 56? Oh,
would it be 7 times 8?
Oh, okay. So what I would do first is go parentheses. I wouldn't distribute here because the only reason why you
because they're like terms.
Well, yeah, because the thing is that order of operations you can go parentheses, exponents, multiplication.
Oh, okay.
So the thing is the reason why we have to use distributive property here, and we can here, it's just it makes it more difficult. The reason why we have to here is because we can't actually subtract those. We can't subtract b and 3.
Right.
Subtract negative 8. So here we have 7 times. That's what I would do first. I think it would make it simpler. So 7
minus negative 11.
Good. And then this becomes
Positive 8?
Good. Yes. Negative
Okay.
169. And then what do you got to do over here?
So you do the parentheses first.
Yes. Mm-hmm.
So, you do, so it would be 4 plus, negative 24.
Good. Okay, now let's keep going. So we're going to just start again, and we're going to just simplify across. We don't know if they're equal, so we put a question mark.
So
Okay.
you do, minus 77
Yes.
plus 8 equals minus 169, minus, oh, and then you do, minus 20.
Mm-hmm. Good.
And then you do, minus 69, minus 169 minus 100. Minus 100?
So the only thing about that is it's going to actually be
Oh, okay.
100.
Oh, okay, because it's two negatives.
Yes. And if you
Okay.
had minus 100, like let's say you had minus 100, then you would be getting negative 69 equals negative 269. What would this, if you got this, what would it mean?
Well, it would end up as a decimal when you divided it.
Well, it would basically, these two things are not equal, right?
Yeah.
So basically what happened here is if that had been a negative, then this would be this answer. And basically
Right.
that would mean that the answer negative 8 didn't work, right?
Right.
But
Yeah.
because we fixed the signs, it is negative 69. What we're looking for here is that negative 69 is equal to itself. The number negative 69 has nothing to do with anything. It's not the solution. That a lot of times students get confused about that. They think it's the solution. It's just evidence that our answer is correct, and we can go back. Now that the check worked out, right? We can go back and state the solution. To state the solution, we say the solution is negative 8, and
It's hard to think of this as 1 instead of 0 because it seems like it would be 0 and
what would be 0? Sorry.
that the answer would be 0 instead of negative 1.
Negative 1. I'm not entirely sure what you mean because I don't see where are you seeing negative 1 and where are you seeing 0?
Oh, but the answer was 8.
The answer is negative 8. Yes.
Yeah.
And so all the check is showing us is that negative 69 is equal to negative 69. Since that's true, it's showing us that the answer is negative 8, right?
Okay. Yeah. Okay.
Okay, so should we do another one? Does that make sense? Any questions on this?
No.
Okay, great.
Okay, so how about these three. 22 A, B, and C.
Okay, so can you just try reading the problems to me?
Yeah.
Okay.
6B plus 10 equals 3B plus 10.
Okay, great. Oh yeah, I know what the issue is here. So I know exactly the 3 problems you're talking about. And so we'll just do them, yes. So this one right here, what would you do to solve for, we're gonna solve for B. The instructions probably say solve, right?
Yeah, so you subtract 3B from both sides.
Yes, you do, good. And you get?
You get 3B plus 10 equals 10.
Good.
And then you subtract 10 from both sides.
You do, good.
and then you get b equals 0.
Yes, well, you would get 3b equals 0, which means that b equals 0, right? Because 3 times
That's what
0,
I didn't understand.
yes, 0 is,
Why 3b equals 0 is b equals 0.
yes, it's the same thing. Because at this stage right here, if I'm solving, I have 0, that's a real number. If I divide by 3, okay? So
Yes.
think about 0 is a very complex number. It's there's whole books written about 0. It took a long time for cultures to evolve and understand the idea of 0. So let's talk about 0. So let's say you have $0, okay? And you are so generous, you're going to split it with me evenly. We're going to divide it by 2 people. 2 people split up $0. How much money do we each get?
It's still 0.
Yes, because 0 has a denominator of 1. Every whole number has a denominator of 1. Every integer has a denominator of 1. So 0 is no different. The number 0 is being divided always by 1. I'm splitting up none of my stuff with myself, Okay,
Right.
but then we have a different concept. So the answer of 0, a lot of students, they don't want to get that answer of 0. That really throws them off. But we can see that 0 is just a number. We can check it. So 6 times 0 plus 10 is equal to 3 times 0 plus 10. So 10 equals 10, right? Anytime you multiply something by 0, you get 0, don't you?
Yeah.
Yeah, that's the 0 product principle.
Okay.
Now, later on, 0 is going to be a little bit, the idea of 0 is confusing in the sense that if you have, for instance, let's say $1 million and you don't actually have it, no one has it. 0 people are splitting it up.
Right.
How much does each person get? Well,
0.
That question actually doesn't even make sense. We call this undefined. So,
Okay.
so 0 is special in the sense that you cannot, 0 is the only number you cannot divide by. If there's $1 million, there is going to be one person who is going to, or 1 or 2 or however many people. But if $1 million exists, it's in somebody's possession. So 1 million has a denominator of 1, right? All numbers have a denominator of 1 that's implied. Like if you see the variable x has a coefficient of 1, a denominator of 1, an exponent of 1, right? There's a lot of 1s around.
Right.
And you could also say you're adding 0 to it. All of these things equal x. When you have just x, you have 1 in front, 1 up top, 1 below, and you're always adding 0 to it, right? If you add 0, it doesn't change. But if you multiply by 0, it becomes 0. But you can never. So one of my students in Math 60 said, we can't divide by 0 because we're not Chuck Norris. Chuck Norris is the only one who can divide by 0. So that was their joke that they told. Okay, so that's a little bit about 0. So the answer to that question was 0. And
instead of 3b equals 0, it's just b equals 0.
B equals 0. Because 3b equals 0. What's the only number that you can multiply by 3? Oops, I didn't mean to put the 0 there. What's the only number you can multiply by 3 and get 0?
0.
0, exactly. So that means that b is equal to 0.
Okay.
Okay, and now the next one. I know exactly what the next one's going to be, but just read it to me anyway.
6b plus 10 equals 6b plus 10.
Yes, okay. So what do you think about this one?
I thought it was 0, but it was actually either all real numbers or no solution.
Okay, good.
Can't remember which.
So let's solve it. So 6b plus 10 equals 6b plus 10. Okay, so if we were to plug in 0, that would make it true. But let's just go ahead and solve it. So one thing we might do is subtract our 6b from both sides, right?
Yeah.
And that would leave 10 equals 10. There's no more b's left. But is 10 equal to 10? Is that true?
Yeah.
Okay, so this means all real numbers.
Oh, because 10 equals 10?
Yes, because 10 equals 10 is a true statement. And if you
Oh.
plug any number in for b, let's say we tried to plug in 2 for b. 6 times 2 plus 10, is that going to equal 6 times 2 plus 10?
Yeah.
Yeah, so you could see right away in this problem, the two sides were already equal to each other, right?
Right.
That's kind of like saying 2 is equal to 2.
Yeah.
Doesn't actually matter what b is. Anytime you plug any number in for b, it's going to be the same thing on both sides, so it's going to make it true.
Okay.
Okay, so what do you think about, let's do the next one then. What do you think, what's the next one?
No solution because it's not true because 0 doesn't equal 5.
Yes, so it's something like 6b plus 5 equals 6b.
It's 6b plus 10 equals 6b plus 15.
Right. And so here was a 10, here was a 15. We can see right away if I subtract 6b from both sides, again, my b's are gone. I'm left with 10 equals 15. But 10 is not equal to 15. This is false, right?
Yeah.
Since 10 does not equal 15, means we have no solution, because no matter what, if you multiply a number by 6 and you multiply the same number by 6 and then you add 10 or you add 15, these numbers are never going to be the same, right?
Because it can't be b because it can't be b equals 5 because you already canceled out the b's.
Exactly. Mm-hmm.
Okay.
The b's are gone. So with no solution and all real numbers, the same thing is always going to happen. If you wanted to write an equation that was always true, you could balance out the equation. 2b equals b plus b. This is universally true for any number, right?
Okay. Yeah.
But something like 2b plus 5 is equal to b plus b, it's like that's never going to be true. It doesn't matter what number you put in, because we already know that this has 5 more than this side. So there's no number that I can put in for b where that's going to be true. So one thing I always say in my class, I will be saying it in my class in fall because I'm a broken record, is I say to my students, okay, there's like a, meme on Facebook or something, and it says, math gives us hope that all problems have a solution. And I say, no, that is not true. Math does not give us hope that all problems have a solution, because there are problems that have no solution.
Right.
Yeah. So that's good to know. We can have problems that are always true.
Right.
This is a universally true statement, or we can have problems that are never true. And we can have problems that are sometimes true. Like if I say 3b is equal to, I don't know, 2b plus 3. When we solve this, we get b equals 3. This equation is only true for one number.
Yeah.
Right? So we have 3 different scenarios. And in fact, when we get into more advanced math, we have more than 3 scenarios. We could have equations that have more than one solution. Not an infinite number, but maybe they have 2 solutions, or they have 3 solutions, or they could have 5 solutions. So the point is that you right now have 3 different case scenarios, all real numbers, no solution, and 1 solution.
Okay.
Okay. All right. Any other questions?
Yeah. 3q equals 7-8q plus 8.
7AQ?
No, 7/8.
Oh, 7/8 Q.
Yeah.
7/8 Q, and then, sorry, what was the rest?
Plus 68.
Plus 68. Okay, great. Okay, so again, now this one is not everything has a fraction, but everything can be turned into a fraction, right?
Yeah.
And so we could use the same idea here of clearing fractions. We can work with the fraction, like you could subtract 7/8 Q and subtract 7/8 Q. You could do that, or you could clear the fractions. So my preference is to clearing the fractions. What do you prefer?
Do you have to turn them all into 80 first? Or excuse me, do you have to turn them all into 8 first?
Into eights, yes. So I would turn them all into eights, yes. So
you would do 3 times 8, but you only have to do 3 times 8 because you don't have to do the bottom, right?
well, you're going to eventually get rid of the bottom. So a shortcut way, there's 2 ways to do this. There's getting them all to have 8, or there's multiplying everything by 8. And sometimes people find it easier to do one or the other. So you're going to end up with the same thing either way, but let's just do it this time where we multiply everything by 8.
Okay.
Okay. So we're going to multiply everything by 8, meaning also don't forget you're going to multiply this one by 8 as well, right?
Why?
Because the whole point of multiplying by 8 is that here, the whole reason why we have a fraction, so fraction means divide. So the only reason why we're multiplying by 8 is because we want to get rid of that 8. So if we multiply this by 8, we get 24Q, right?
Yeah.
If we multiply this by 8, we have 8 divided by 8. These cancel, and then what are you left with?
Just 7, right? Because you don't have to multiply. Okay, that was my question. Yeah, you don't have to multiply 8 times 7 because that's already in this lowest common multiple.
Right. Because it would become 56/8, which is equal to 7 over 1.
Oh, I understand. Okay.
Yeah. So now you can't cancel anything here, so you're going to multiply 68 times 8. I don't know what that is off the top of my head.
544.
Okay, you knew that off the top of your head. Wow. Yeah. Okay, so now what should we do to solve for Q? This is what we did, was clearing fractions. That's what that's called. Clearing fractions. And I think I sent a video. Did you see the video that I sent on clearing fractions?
I think so, but I think I watched them. I think I watched them all at once, and then I did the module later, and by that time I'd gotten the stuff that was on the video. I'd forgotten key points and stuff.
Yeah, no problem. But I noticed, it's not only you, right, that asked. A lot of people have this is one of the harder concepts here, because like I can see you have a lot of the basics, and then these are just the harder problems, Okay, so let's finish solving. Right now it's easy to solve, right? I meant to ask you, but I just couldn't help myself. I just went. Okay, so what would I get now?
So you would get 17.
Q, right?
Q equals 544.
Okay.
So you get 32.
Because are you dividing by 17?
Yeah.
Q equals 32. Okay, great. And then remember, we always want to check. So to do our check, we're going to take that number. Oops. We're going to take that number. Oh, I wanted to get a different color. I like playing around.
For some reason, I did 544 divided by 8. I'm not sure why. I think I missed a step. Oh, because I didn't subtract 7Q from both sides.
Oh. Huh. Oh, and then, but didn't you have 24 here?
No, I didn't have, when I did it, I didn't do the 24 either. I'm not sure what I did. I did something really different. Can
Oh,
I, before you erase this one, can I write it down the right
of
way?
course. And I'm gonna send you this video too.
Oh, okay, okay.
Yeah, so you can rewatch this and then go over it and stuff. But let's see. So you did 544 divided by 17. Is that how you got 32?
Yeah, yeah.
Okay. So now what we want to do is we want to take this answer and we want to do what with it?
I'll put it into the queue.
Yes. So we're going to just go to the original problem. So we have 3 times 32 plus 7, 8. Oh, no, not plus. Sorry. I'm writing the problem wrong. Equals. Oops. Equals 7/8 times 32. And that's actually pretty nice because do you know why I think that's a nice friendly number, 32, when it comes to 7/8?
Because it goes into, is it because
8 goes into 32.
because it goes into both of them, right?
Yeah, 8 goes into 32, so I can cross cancel. So if I do 7/8 times 32, I put the 32 over 1, and then instead of multiplying 7 times 32 and then dividing by 8, I can divide 8 into 32, goes 4 times, and then 7 times 4 is going to give me the 28. 28 plus 68 should be 96, right?
Yeah.
And I got the 96 because I'm multiplying those. So 96 equals 96. So right here, this is our check. And then the last step would be to state the solution. The solution, what is the solution to this?
The solution set is 32.
Is 32. Very good. And I ask that because a lot of times people get confused. They will say 96 is the solution. But 96 has nothing to do with anything. It's just showing.
It shows that they're equal.
Exactly. Okay, very good. Okay, any others that you want to do? I could probably have time for one more.
Okay, one more. How about, let's see, how about maybe another, if I can find another fraction, because those are so hard for me.
I know. And actually, if you don't mind, I would even share this video with the class because they could see, some of the fraction problems. You're not the only one. Everyone struggles with fractions. This is the most challenging of all of the problems that we've done.
Okay, this was a hard one, and yeah, I don't mind sharing it. That's fine.
Cool.
Okay, this was number 18, and it was r over 3 minus 12 equals r over 7.
Equals r over 7. Okay, great. Okay, so what should we do? Any thoughts first?
So the common denominator is 21.
21,
so
okay.
It's, so you would go R7 over 21 minus 252 over 21.
Okay. Oh, yeah. So you're going 7 over 7. Oh, I see. 3 over 3, right? Multiplying by 3, multiplying this by 21 over 21, right?
Yeah.
Okay, great. And then, so we would get 7r over 21 minus, what'd you say this one was? Sorry?
252 over 21.
Over 21, good. Equals?
3r over 21.
Good. Okay, and now that's the first step on clearing fractions, right?
Yeah, you can get rid of the bottom row.
Yes, so we have, what's the equation we're going to solve then?
Is it minus 18?
Oh, wait, where's the 18 coming from?
I'm not sure. This is when I did it before. I don't know what I.
Okay. Well, let's just start from here. So I have 7r minus 252 equals 3r. So basically, just because we got everything to have a common denominator, we could eliminate that denominator.
Minus 245 then, right?
245. Where's 245?
Oh, no. I was subtracting.
So,
Okay, so no, you do minus 7 from both sides.
yes, minus 7r, good. Minus 7r, good. Okay, and then we would get?
Minus 4r. So you would get minus 252 and minus 4r.
We divide, right, by negative
Uh-huh.
4r.
63.
63.
Minus 60. Or would it be it'd be a positive because it's two negatives.
Very good, very good. So that's your answer there.
Okay.
And then we always want to make sure that we go back and check. So we have 63 over 3 minus 12 equals 63 over 7. And again, this number 63, the solution is going to be 63. I'm pretty sure it's going to work out. What's nice is that these numbers are divisible. So these can become whole numbers, right?
Yeah.
63 divided by 3 is, do you know?
Yeah.
What is it?
21.
Good. 21 minus 12 equals, do you know what 63 divided by 7 is?
Yeah. 9.
9. Good. And then, so we're wondering, is this right? And this looks like it's true. 9 equals 9 means our solution.
The solution set is 63.
Yes, very good. Very good. I think you're doing excellent. Yeah. So you just have to try, about 300 more problems like this.
Right.
And then you'll feel super confident.
Thank you so much. Yeah.
And also realize that if you did want to, well, at this point now, WebWork will be open, so you can go back in and you can see the worked out solutions. So you should be able to see that. And then another.
Oh, if you go into the thing, you can check and see the ones that are your actual problem, not the one that's kind of like your problem.
No, it should be your exact problem worked out in WebWork.
Can you do that with all of them through module 1? Can you go back and look at how they worked out all of them?
Yes.
That would be really helpful.
Yes. So that's one option. Another option is some students were wanting to do more problems, and that's always encouraged. That's completely acceptable. So if you did want to, your textbook has, at the end of each chapter, it has a whole list of problems. And there was a while back, I sent out the link to the answers to the odds. But when it comes to solving equations like this, you always want to check it. So really, it doesn't matter if you have the answer key or not for a problem like this, because it's nice.
Yeah, I need to see how it's worked out. It doesn't, if I just have the answer, it doesn't help me because I don't know how to get to the answer.
Exactly. That's so true. So, and then, you can always send me ahead of the deadline. You can always send me questions, so I'll go ahead and stop our recording, and then we can, because I'll share this with everybody.
Okay.
Right? Because I think that these problems are really helpful.